I have seen some of you abuse notations. I know what you mean, but you still need to write it right. Okay. The first abuse notation, when you do implicit differentiation, let's say y equals to sine y equals to e to the 2x, and then you do implicit differentiation, right? Okay. Either you write this implicit differentiation, okay, or you write derivative respect to x on both sides. Okay, so you write d of sine y dx equals to d of e to the 2x dx. That's how you write it. Now, the following is abusive, and I will use the word abusive because if I, for some strange reason, if I use the word wrong, you don't care. If I say incorrect, you don't care. But we get ticked off with the word abuse, right? So let me use the word abusive so that you know how bad it is. Okay, the following is abusive. That's abusive. That's not right. No, I know what you mean. You are basically, you do the derivative on left and right hand side. Okay, but how do you get the derivative of equal sign? Huh? No, that's abusive. Okay, whoever taught you that is okay, that person not learning math high enough. Okay, no, that's abusive. But Thomas, I don't think the word abusive is appropriate. It is very appropriate. What is the root word of the word abuse? What is the root word of the word abuse? You're a native speaker, most of you, so you're supposed to know this. Right? The root word of abuse is, the root word is use. Now, if you don't use that, if you use that inappropriately, then you have include the word abuse. Just like the word abnormal, the same idea. Okay, so abusive is basically you use that inappropriately. Simply because you think you can use it and you use it that way. No, that's not right. Okay.
So I had a question about this because I got dinged on my first quiz for this.
And the second quiz also maybe?
Maybe. but, on both sides, my previous professor would write or would put the equation not like all together with the equal sign in parentheses, but on both sides he would put them separately in parentheses and put the d over dx on either side. Now, was he wrong to do that?
To do this?
Yeah, that, or put the d over dx in brackets right next to the equations.
That's not right, though. That's not right. That's not right.
Yeah, either of those are not right. Okay.
Okay, the one on the left hand side, this is right. This is basically
so you put the equation in the parentheses. Okay.
Yeah, this person who abused that put the equation in the parentheses. No, that's not right. Okay. Now the one on the left hand side here, this is correct.
Yeah, that's what I meant. Right.
Yeah, this is correct. Okay, but this is not right. This is not right. The notation, derivative is an operation. So it's supposed to be written in the front of that expression. Just like a function.
Damn, I've been doing this wrong this entire time.
Yeah, so just like a function.
That's what my calculus teacher taught me.
Yeah, well, sometimes I understand some of them just try to be nice to you, and then they don't ding you if you use that notation, or some of them even abusive themselves. Like when they write the notation, they just want to do it super fast. But still, if they want to write it super fast, use that underline. You know, use that underline and put ID like that for implicit differentiation. You know, okay. So no, this notation is incorrect. Yeah, if that person dare enough to come to me and say, Thomas, why you mark it wrong? Or like that professor come to me and why you mark this wrong? And I would tell it's like, will you write your fx as, will you write this as xf? Will you write it that way? No, they are not the same. Everybody knows that's not the same. The function notation always written before that n supposed to be with parentheses. So it is actually, some people will penalize you if you write it this way. That's actually not really right. It's supposed to be with that parenthesis because that d dx is an operation. You can see it as an operator. Basically, it works on a function. It's like a function of function. Think of it that way. And an operator always written before the expression or before the function you work on. You know, so if you go after your calculus 2, some of you will take the differential equation. In differential equation, you have that operator d, for example. Okay, d of y, d of f, and you cannot write f of d. No, that's wrong. Because this is not d times y, this is not d times f, just like this is not e to the 2x times the differential notation or derivative notation. No, it's not multiplication notation. Okay. So yeah, no, that's one. What else? There's one more. And when I saw that, it's like I feel strange. Oh, another one is this. I write it on the notes. I don't finish the grading all your quiz 2, 3, 4 yet, or I don't remember 3, 4, 5, I guess. Okay, I'm not done with grading all of you. There are still 4 people I'm not done yet. But I saw some people doing integration by parts in the following way. Let's say this is x cubed, and this is e to the x squared dx. Okay, and that person don't show me anything but integral 1/2 u e to the u du. Okay. The rule of thumb is when you do substitution, you're supposed to say it explicitly. What is your u? Equals to what? Okay. You're supposed to write that explicitly. Okay. Look at all the calculus textbook. All of them, when they do substitution, they will show it. Okay. Now, the strange thing is you skip this, but then when you do the phi du u d phi, like f equals to u, f prime is du, g prime is e to the u, so g is e to the u. It's like all of a sudden you show this, you know, kind of strange, to be honest with you. Kind of strange. It's like things that you are not supposed to skip, you skip, but things that you can actually skip, like product rule, chain rule, those are things you can skip. You don't skip instead. You know, so pay attention to what details you need to show though. I'm telling you this not simply because I want to deduct you points. Yes, I want to deduct you points. Huh. Okay. It's more about that you need to know how we write our math. And keep in mind when you write your math, it's about making other people understand what you write. Okay, so there are some tradition you need to follow though. Okay, there are some tradition you need to follow. So in this case, Thomas, what I need to write? You're supposed to write this. Okay, the substitution. So du equals to 2x dx, and then you rewrite this part here. Break it down. I can understand if you don't do that. I still can understand that. And this becomes u e to the u and then du over 2. Okay, and then you take the 1/2 out, u e to the u du. And then from there, yes.
I think the one thing that's always been tripping me out and it's making me second guess basically all my u substitutions is like, for instance, you know, like how you put u equals x squared. What happens to the other power since x is cubed in the beginning?
Oh,
What
I
does
rewrite that x cubed into x squared times x. Yeah, I need
okay.
one x to help me with the du.
Okay, see that's okay, because
That's
that
why you need that now you actually confirm that you're supposed to show that the rewriting.
damn it, Thomas,
See,
why did you teach this class? Why did you teach calculus? Damn it.
I am teaching calculus.
No, calculus 1, I'm sorry.
Okay, because there are some people cannot teach calculus too,
I guess so.
right? If I teach
What is
calculus 1 and they cannot teach calculus 2, you know what will happen? They always get different answer. They blame it on the book. It's typo. we had that case before. We had that case before. And when we found out that person, we never let that person actually teach calculus anymore. And eventually that person get kicked out. Whenever he get different, it's a guy, it's a male instructor, by the way. It was like around 7 years ago. It's like always just blame, always. And I can give you one hint. That person didn't use textbook in our class. That person didn't want to use calculus textbook, didn't want to use our trigonometry textbook because yes, it's like a lot of typo. It's just like, no, I used that book for like 5 to 7 years prior to that, and I hardly see typo. And then he said, oh, it's too many. And then when I see students' note from his class, because they asked me questions, then I found out, no, this person didn't do it right. Well, anyway, then come back here. Okay, it's my u already u, then just leave it as u, and then my phi be e to the u. So du equals to du d phi.
I have a quick question right here, Thomas.
Uh-huh.
So I ended up changing the variable here because I wasn't sure that we could
That's
use
fine.
u again.
That's okay. That's
But
okay.
you dinged me
It
off.
just happened to be. I don't think that's the reason I take your point off. I will see again later on, but I don't think that's the reason. I don't think that's the reason.
Never mind. I think you're right. Yeah.
Okay, and then this is 1/2 u e to the u minus integral of phi du. So minus phi du, so e to the u du. And then you substitute. Now, I saw some people use this notation, another abusive notation. Integral of f g prime equals to f g minus integral of f prime g. That is not true. That is not true. The correct one is integral of, supposed to be u dv, right? U d phi equals to u phi minus integral of phi du. Now, if you insist to use f and g, fine, then it should be f dg. It's differential, not derivative. It's differential. Every time you use integral, you're supposed to have the d something. Okay, you're supposed to have that d something. Okay, so the correct one is actually integral of f dg equals to fg minus g df. If you really want to use f and g, that's what it looks like. Not f prime g prime, no. Okay, to be more precise, some of you misunderstood that u prime equals to du. That's not true. This is derivative notation. This is differential notation. Now, u prime stands for du dx. Okay, So let's say your u equals to e to the 2x, right? Now then u prime equals to 2e to the 2x. However, if you write du instead, then it has to be 2e to the 2x dx. Either this one or this one, but not du equals to 2e to the 2x. No. If you do differential on one side, then you do differential on the other side. Okay? So be consistent. If you use differential notation, what happened? If you use derivative notation, what happened? However, when you use integral, it is differential notation, not derivative notation. Okay, so this one is not true. This is not true. Now, believe it or not, whoever used this in your quiz 3, 4, 5 may very likely also use the same in your quiz 1, 2. You are the people who keep on missing the dx thingy when you integrate, and you think that's fine. No, it's not fine. It's not fine. But Thomas, you know what I mean? No, I don't. I don't try. I have one wife. That's one too many. And if you don't write it right, don't expect me to understand it right. Okay? And in fact, as an instructor, I need to fix you that. I need to tell you that's not right. Okay? So no, differential, and she is probably clapping in the back. Who is she? Oh, my wife. Huh. The damage already done. Don't worry. Yeah, we are married already. You want to regret? Okay, so please. This also show your maturity in math though. So imagine if you pass this class and you still have this kind of strange notations here and there. Where do you want me to put my face in front of your calculus 3 and your differential equation instructor, right? Okay, they will say, who is your calc 2 instructor? And when you say Thomas, that will embarrass me, you know? Okay, so right now I embarrass your calculus 1 instructor. Who is that? Let me know. I will need to bring this up to the department meeting next week or 2 weeks later. No, you need to know the difference between differential and derivative. Okay, I know some of them like to say, Thomas, if they know how to do derivative, I'm happy enough. I said, well, the reason they don't know how to do derivative maybe because they don't know the notation right. Okay.
What is the difference? Because as far as I can tell, the difference is notation. There's no difference between the actual derivative.
It's very different because you cannot integrate x. No, there's no such thing. We can only integrate x dx. Right? So if y equals to, keep it simple, x squared. Now, what is dy? Is 2x dx. Now, dy dx is 2x. Now, the difference of these two, okay, has a lot to do later on. You're supposed to see that already in calculus 1 when you do linear approximation. Where we say that the linear approximation of a function is equals to the value of the function at a plus the derivative of that function at a times dx. Without that dx, it's no. Okay, without that dx, then you will not multiply by the difference of x 0.5, let's say, or 0.02. Okay, now, of course, then you will not see that problem if you don't even do linear approximation, though. Yeah, so why don't we just skip everything so that there's no problem? No, it's different. Okay, it's different. Yes, so those are 3 issues that I raised up to you.
Thomas, I have one other question on that from an issue that I got marked down for on my quiz.
Okay, which one is that?
If you scroll up a little bit, right in like the U substitution there, at the beginning of this problem.
This one here?
No,
This
like
one here?
further up.
Further up.
Right in on number 2 there, the x to the third ex2. Like when I did my U substitution, I will sometimes add an extra step there between, like just mentally for canceling out the extra x there. I will sometimes write between your second and third one there on the left.
Oh, here.
I would
from here.
sometimes write an intermediate step where I have the u's, but then I still have an x on the top and the bottom. So
Not supposed to. Yeah, that's actually another issue. Not supposed to. Once you do substitution, then you don't use. Once you substitute, then you don't go back to the previous variable you use.
Right, but just in the like, I have both the things you wrote, and I just have another one in between. So to like make sure that that I have the x on the top and bottom and they cancel. It's more just for my own mental clarity.
The thing is like, because you write it down, I have to grade it.
Right, but like it's not an incorrect statement.
It is an incorrect statement. It is incorrect. Because x is x a function of u?
X is a part of du. Where did the x disappear to?
Well, yeah, well, x is part of du, so that it is a function of u. So you should be able to change that in terms of u.
What I mean though is, so you have du is 2x dx. Replace dx with 2x, or with du over 2x. The 2 remain, but what happened to the x?
I know what you do. It's not that I don't know what you do. What you don't know is that having x when you already do substitution to u is not allowed. This is what you wrote, I believe. So you change that x squared becomes u. So this is e to the u, but you still have x here, and then you write du over x like this, right?
Yes.
Yeah, you just want, I know that you just want to show that the x cancels. Okay, but why don't you think this way instead? This is your x dx that you need.
Yes.
Right.
I just
if you really want to, if you want to have that x there, substitute that into square root of u.
But that's adding further complication. What's easiest is if I mentally, for me, it's easier rather than saying that du equals.
When you say it mentally, don't write it down. Your mistake is you write it down when the variable of integration is u, but you also still have x. So you cannot say that you would do it mentally, but you write it down, expect me to see that as something you do mentally. No, I cannot, because you write it down. I cannot mark you down for anything you do mentally, just like I cannot give you any points for anything you do mentally. Right? Okay, but once you write it down, then I have to say something if it is not correct, and that's what I do. And I said it many, many times though, not only one time. I said it many, many times during my lecture that if you do substitution, then you should not have the previous variable still being used. No. Now, simply because your previous teacher allowed that, doesn't mean I have to allow that.
In a lot of contexts, it's often you do extra stuff that you're not showing between those two steps.
Between, you mean between this one to this one?
Yes.
Which part do I skip?
Your 2x dx, you're putting in and then adding the divided by 2.
Okay, so let me just write du over 2 equals to x dx then.
Okay, and what I did was write dx equals du over 2x.
Yeah, but
and
you
then I put those in and then I cancel them out.
That's the thing. You still have x into your integration with variable of integration u. That's not allowed.
But I'm not integrating anywhere in there. There's still, I'm canceling it before I do any operations.
Why don't you cancel it before? Why don't you cancel it before you put it into the integration then? Which is what I do actually.
I understand I can do it and not write it down, but it's a lot easier to make sure that I'm doing everything right if I write everything down, is all I'm saying.
Yeah, but
and I'm not putting anything that it.
But I also at the same time have to mark you wrong if I see something wrong.
I don't think it's wrong.
Well, you grade it yourself, but when I'm the one grading it, I mark it wrong. That's why I'm the one. I mean, that's something I don't know how to tell you, right? If you think it's not wrong, then well, good for you. But if it is up to me, I mark it wrong. That's why I mark it wrong, because it's wrong. What it feels like right now is that you insist that it is not wrong and you want me to change my mind. I'm not changing my mind. If you don't want to change your mind, fine, that's fine. You just keep on writing that and I keep on penalizing you for that. Okay, and hopefully you still can pass with an A with that. I mean, seriously, okay, I know what you mean, but I cannot say that it is right. Especially from someone who already taught calculus 3, where you have multiple variable. See it as a feedback from me and learn from that. How do you then manipulate that further such that once you change your variable into u, then all of your variable there is u. That's single variable. You see? Okay, but if you don't want to take my feedback, what can I say? Right? What I cannot take is like, you don't want to take my feedback, but you want me to take your feedback. That it's supposed to be okay. No, it's not. It's not okay.
I suppose as long as we don't write the equal sign on it, it's not equal. It's just what's on the side until.
Repeat it again. Sorry, what you say get cut off.
If I don't put the equal sign on it, so it's integral x cubed e to the x squared is not equal to, but we're working on it. Use substitution, cancel out the x's, then put the equal sign on the integral u e to the u.
Basically, what happened is this: under a single integral, you should have only one variable, not two variables.
I understand the concept.
Yeah.
That's why I'm saying though, in order to organize thoughts and order in which things are replaced with the U substitution, you want to, have a notes on the side. And if that includes having a U and an X on the side until you're completed and then put it back.
Into the integral.
Right.
Yeah. So do the substitution and canceling thingy outside of the integral, such that when you put it into the integral, then it's already only one variable.
Right.
So let's see. Let's see how we have x squared e to the x squared x dx, right? And then our u is x squared, our du is 2x dx, and you want to substitute your dx as du over 2x, right? But the thing is, I cannot put this thing in there. So you have two ways. Either you substitute that x by square root of u, which I honestly don't like. Okay. Or another way is like you see, oh, you know what? I have that extra x there. Let me just multiply by x right away. Like that. So you see this as a package instead of just the dx by itself. So from there, you have two possible substitution, either a u e to the u square root of u du over 2 square root of u, or e to the u e to the u and then du over 2, in which you see this as u, this is e to the u, and this is du over 2. Or you see that as this is square root of u, and this is du over 2 square root of u. Like that. But basically, once you put it into an integral, it should be one variable. Okay, now can I be more honest with you? I myself did it your way before until I get an instructor who say that's not right. Okay, now he was someone I respect so much, such that when he say it's not right, I said, my previous teacher let me do that, and I wonder why it's wrong. It's not about penalizing, it's more about, so that's my discussion with him at the time. And he said, Thomas, it's just not because of that, because in one single integral, you should have only one variable. Any other variable is considered constant, and it has something to do with what you see in calculus 3 later on. Okay, and then I said, well, okay, let me try to absorb that first. Then the next meeting I met that instructor, he said this to me. He said, Thomas, one rule that I always follow. So I have an instructor who tell me what's wrong with me. He kind of felt that I didn't really like what I get. Okay, but at the same time, I have my trust in him. So he said this, Thomas, you open those calculus textbook and find if there's any case where you have an integral with two different variables, where those variables, one of them is function of the others. Okay, if you can find that, then I will yield to you. Okay, now then, this is back in Indonesia. I told you that we have 3 textbooks plus 3 supplemental textbooks. So of 6 textbooks I look at, there's none of them like that. So at that point, then I realized that what he say is true. And what I learned from my high school calculus teacher was actually just try to make it visually entertaining, which is true. Okay, it helps. It helps with what you write. Okay, what you write there, where you write it this way, it helps to see that the x cancels. Okay, saying that it helps, that's correct. But technically speaking, you are not supposed to have two variables in a single variable integral. That's the one that he emphasized so much with me. You know, so I was in the same issue before. It's not that I did. That's why right now I can tell you the answer, because my instructor, my professor at that time, marked me wrong. I didn't talk too much about that. But the one I appreciate from him is actually he approached me again the next day. It's like Monday, Wednesday class, I remember. So the next time I met him, he actually talked to me before class. I said, Thomas, you know what? Let me challenge you this. Try to take a look on all Calculus 1 Calculus textbook. And if you see a case where you have two variables in one single integral, let me know. And I start thinking, oh, that's a big challenge. You know, if I can find one, then I will. It means not only I get my point back, but I also get he is wrong. And it turns out that I never see that. You know, just like this though, just like this, a mistake that I penalize in my pre-calculus classes, and even in my college algebra classes, you can ask Shane. The following. Okay, I make it as simple as possible. 2x minus 3 equals to 5. 2x equals to 5 plus 3. 2x equals to 8 divided by 2 divided by 2. X equals to 4. Okay, the answer is correct. But if you are in my pre-calculus class, I will penalize you 1 point for this. For two small mistakes. The first one is this. Your equal sign does not form a line. Okay, equal sign when you solve an equation is supposed to form a line. Now, of course, when you do handwriting, it's so hard to put that in straight line, right? Okay, but at least you try. This is definitely not something you try to make it straight. So if I see this in my algebra class, I will penalize half point for that not being straight. Now, of course, then somebody may argue with me, but Thomas, I get the right answer. Yes, you get the right answer, but I penalize you for the way you write. What it has to do with the way I write? Well, if you are in my training, then I teach you how you're supposed to write it. You know, after my class, if you still want to write it that way, what can I say? Right? But in my class, I need that equal sign to be straight when you solve an equation. Now, the thing is, you will not be happy if I enforce this in your class. Right? But at the same time, at this point, you're supposed to know this already, though. You see what I mean? Okay. Whoever does it this way will get the answer right. So what's wrong with that, Thomas? As long as I get the answer right, it's about the fact that equal sign always straight, and you can open 20 calculus, 20 algebra textbook, all of them like that. All of them like that. Okay. So it's call it the tradition. The tradition in writing math, like when you solve an equation, the equal sign should be straight. Okay. Well, at least I don't penalize. I hope it doesn't happen in your test one, such that I don't need to penalize you in your test, you know, right? Because mistakes that happens in your test will be a lot worse. It will affect your grade a lot more compared to quizzes. Okay, quiz is more or less where I get your feedback from you and I fix how you write things. Okay, and I think if you have this case, I penalize only half point for this. Yeah, for this kind of incorrect writing, you know, I penalize you half point. It's kind of like you call that as a slap on your hands, like a little pinch on your hands, right? I don't want you to see that as something very terrible. Okay, but it's definitely not allowed. It's not something you want to do, especially when you go to your calculus 3 or differential equation. It's terrible. Later on, if you will see it, you find that to be very terrible. Okay. Let's see. Any more question for material for test 1? No more? Let's get to 7.5. Then should I start recording now? Oh, I'm recording already. Okay, let's go to 7.5. Any question you want me to go over? So your test one only up to 7.3. Okay. 7.5, number 21, 30, 59, 65. Okay. Oh, number 5. Thank you. Sorry, I didn't see that above. Okay, number 5, 7.5, number 5. Now, the thing is, in this 7.5, basically they combine whatever technique of integration we learned before. So there could be some questions like number 5 may be harder than number 20. Okay, it could be. In other words, they basically just give you combo. Okay, now let's see number 5. Integral of t over t to the 4 plus 2 dt. Oh, you know what? Let me ask you this question. Before I go too far. What is integral of t over t to the 4 plus 2 dx? What is this equal to?
Isn't that tangent inverse?
No. The one on the right-hand side here? No, it's not.
Well, isn't it? Well, I mean, oh, never mind. Sorry, okay, never mind.
Okay, let me tell you the answer. The answer is t over t to the 4 plus 2x.
Wait, sorry, could you explain that?
I can. The variable of integration is x, not t.
Oh, got it.
Right? Yeah, the variable of integration is x, not t. So if you have any expression with other variable, okay, then you integrate respect to x, not respect to that t. Okay, now of course that that answer here on the right hand side definitely is different from the one we have on the right hand side. Okay, now but I will say it this way. I will use my u equals to t squared such that du is 2t dt. Now notice that we have t dt here, right? Okay, so I will make it du over 2t equals to t dt and then do substitution. Integral t dt will be du over 2, and then this is 1 over u squared plus 2. That's 1/2 of integral du over u squared plus 2. Now what? This is 1/2. I hope you remember the integral of 1 du over u squared plus a squared is equals to 1 over a tangent inverse of u over a plus constant. Right, so this one will be 1/2 for the 1/2 outside. Okay, and then this is square root of 2 being squared. So I get 1 over square root of 2. And then tangent inverse of u over square root of 2 plus constant. Now then I substitute my u back. That's 1 over 2 radical 2 tangent inverse of t squared over radical 2 plus constant. Okay, now in my class calculus 2, I don't mind you to leave it like this. Even though you need to be a bit careful, there are times if you simplify, rationalize the denominator, then you get a better, simpler answer. Okay, so some textbook and some instructors prefer you to answer it this way. Basically rationalize the denominator. Okay, but in my class, I don't mind if you leave it like that, as long as if you rationalize that it's not any simpler. Now that's a bit vague there, because even the word simpler at times is not clear in different cases. Okay, but this question here and requires your imagination. How should you substitute such that you catch one of the form that we get used to work with? Okay. Is it okay? Who asked me this question? Robert, is it okay with this? Okay, let's see the next question. Number 21. Number 21. Integral of arc tangent square root of x dx. Let me rewrite this into the form that I get used to. So this is tangent inverse of square root of x dx. Let's do substitution first. So if u equals to square root of x, then u squared equals to x. So this is actually another method. You solve for x first and then you do the derivative. Remember we have that u equals to x squared, right? So another way is actually you solve for x first and then you do the differential. Because you insist to have dx, right? So then on the left-hand side, you will have 1/2 square root of u du like that. Okay, so what I did just now for this question number 21, I solve for x and then I do the differential. I get 2u du equals to dx. Now, therefore, therefore then my substitution becomes integral of, let me continue here, integral of tangent inverse u times 2u du. Oh, I can do integration by parts right away here. So this is 1/1 plus u squared. This is u squared. Right? So that's u squared tangent inverse u times, minus integral of u squared over 1 plus u squared du. Right? Okay, and then this is u squared. I will substitute that u back to x later on. How do you do this? Let's manipulate the top. So u squared plus 1 minus 1. Okay, so I add and subtract 1. My purpose is so that this guy here becomes 1. You see that? Okay. So in my next step, I will break it up into 2 integrals, but one of them a nice one, and the other one is not so bad. So the first integral will be u squared plus 1/1 plus u squared du, and then plus integral of 1 du over 1 plus u squared. Okay, so this is the one I circled in blue earlier, and the second part here is this. Okay, now it becomes plus because of this negative and another negative here. Now once we get that, then I will just integrate Oh, you know what? Let me fix it a little bit. So this is u squared tangent inverse u minus integral of du plus integral of du over 1 plus u squared. That is u squared tangent inverse u minus u plus tangent inverse u plus constant. Okay, so that will be
Wait. Did I miss that? What happens to one? Shouldn't it be minus the integral of du?
Repeat it again.
The negative, the last integral, du over 1 plus u squared.
Uh-huh.
Should that be a negative? Shouldn't that be minus?
Oh, the coefficient?
Yeah.
It's plus because it's minus here with another minus here.
Yeah. Okay.
Okay, yeah, so these two negative. Okay, now then I will substitute, what is u again? U equals to square root of x, so u squared equals to x. Okay, so this becomes x tangent inverse of square root of x minus square root of x plus tangent inverse of square root of x plus c. I believe our textbook will factor the tangent inverse of square root of x. Yeah, even though I admit that if you leave your answer here, this is okay. Okay, that's for number what? Number 21, number 30. Please interrupt me if you have any question. Okay. So yes, that the sign that you have concern earlier. Yes, just let me know. It could be my mistake though. It could be, oh, number 30, that's effing hard. So absolute of e to the x minus 1 dx. It's more about when will this supposed to be always positive, right? Okay, but we cannot just take it off as if no absolute sign there. No, you cannot do it that way. Okay, no, you cannot do it that way. Okay, you need to first look at that e to the x minus 1. When will that be positive? When will that be negative? Okay, so this will be, do the sign graph. Okay, the critical number. Step 1, the critical number, e to the x minus 1 equals to 0, e to the x equals to 1, so x equals to 0. Okay, and then step 2, the sign graph. It will be positive on the right-hand side. It will be negative on less than 0. Okay, now then you break that integral up, becomes integral from -1 to 0 of that absolute e to the x minus 1 dx plus integral from 0 to 2 of absolute e to the x minus 1 dx. Now then, the second integral here in this domain 0 to 2, e to the x minus 1 is positive, right? So I can take off the absolute sign. Again, the explanation is because e to the x minus 1 is at least 0 on that interval 0 to 2. Okay, now e to the x minus 1 is negative on the interval -1 to 0. Okay, that's why then when I take off the absolute sign, I need to put opposite. Like that. Okay, that's basically integrals -1 to 0 of 1 minus e to the x dx plus integral 0 to 2 of e to the x minus 1 dx. And I think you can take it from here, right? Yeah, I think you can take it from here. Again, the issue is really, what do we do with that absolute value, Thomas? How do we deal with this? And the way we deal with this, we go back to our pre-calculus, where we say that absolute of blah is equal to blah if that blah is non-negative, equals to negative blah if that blah is negative. Does it make sense? Now the thing is, when is the cutoff? What's the x when e to the x minus 1 change from negative becomes positive, positive becomes negative? That's where we find the critical number. Okay, I think that's the issue if you ask me that question. I don't expect you to have issue on how to integrate this, right? Just do it term by term. Okay, and plug in numbers. Yeah, you do it yourself from there. To be honest with you, every time I teach this class, I always have that question from this number 30. Yeah, I always have that question from this number 30. Apparently, no, it's not your calculus instructor's weakness. It must be something to do with how your pre-calculus instructor enforce how to treat absolute value in your equation or even in your function. Now, if you look back into my pre-calculus class, I did ask this question. For example, absolute of x minus 3 plus absolute of x plus 1 equals to 5. And I asked them to solve it. Now, think about this, though. Think about this. Okay? Think about how to solve this. It will not show up in your test, don't worry. Maybe what happened if I ask you integral from -3 to 5 of absolute x minus 3 dx, right? You see what I mean? So you need to find out at what x minus 3 is positive, at what x minus 3 is negative. Does it make sense? Okay. So the one related to you is this type of question. But the idea behind that question is basically what you learned from how to solve this equation here. And this is a question from, I don't know what it looks like. This is a problem from our pre-calculus class, by the way. It's in our pre-calculus textbook, similar to that. Okay, what do you do with absolute value, Thomas, in the integral? Yeah, that's how we do it. That's for number what? Number 30, number 59. Oh, that's the next page already. Uh-oh. Number 59. Integral of cosine x and cosine cube of sine x dx. Okay, substitution first. U equals to sine x, so du equals to cosine x dx. So notice that this is my du. Okay, that's my du. And then that integral becomes cosine cube u du. Now, how to integrate this? That's cosine squared u cosine u du. Give me a second. And then let me continue here. Oops. It doesn't show up. So this is integral of 1 minus sine squared u cosine u du. And then I substitute again. Let's call it w equals to sine u. So dw is cosine u du. So I get integral of 1 minus w squared dw. W minus 1/3 w cubed plus constant. What is w? That's sine u. Oh, the final answer will be so nasty, huh? That's 1/3 sine cube u plus constant. And I still need to change that u. Uh-oh. That's sine of sine x minus 1/3 sine cube of sine x plus constant. Okay, is it okay so far? Let me scroll it up a little bit. Yeah, so we need to do 2 substitution here. And then what is the other one? I remember that's the last one for this section here. What's that? Number 65. Number 65. Integral of sine 2x, sine 2x over 1 plus cosine to the 4th x dx. Oh, this one is a bit tricky. This one is a bit tricky. But notice that at the bottom you have, on the denominator, you have 1 plus something squared, right? You see what I mean? That's 1 plus something squared. Now, what is that thing that you square? Call that your u. You see? Okay, so later on, after we do substitution, we will get 1 plus u squared at the bottom. Is it okay? Now then, what is du? Du will be 2 cosine x times negative sine x dx, right? Now, but 2 sine x cosine x is sine 2x. Okay, just note, remember this. Sine 2x equals to 2 sine x cosine x. Okay, keep that in mind. Now, trigonometric identity supposed to be something in your blood already. Now, I know it depends on your preparation in trigonometry and pre-calculus, right? So I have notes. I let you have your notes. The thing is, if you don't really practice, it's kind of hard for you to realize, oh, you know what, there must be a formula for this. I remember there's a formula for this. I just don't remember clearly. Then you see your notes, right? Now, if you don't get used to do your exercise, you may not realize that there's a formula for that. Okay, but this then becomes, you see, this is basically our negative du, right? That's our negative du. Okay, so that's negative du. So now we get this is equal to, let me just do it next to it, negative tangent inverse of u plus constant. That's negative tangent inverse of cosine squared x plus constant. Okay. But I don't think we can simplify that any further though. Yeah, I don't think we can simplify that any further. That's the furthest we can go. It's already in terms of x anyway. So that's for number 65. Okay, let me do one more question before I jump to the next section 7.8, or I give myself a break. I look at number 67, I have no clue. So that's dx over square root of x plus 1 plus square root of x. Dang. How to do that one? I have no clue with this. Honestly, I have no clue. Oh, you know what? Let's multiply by the conjugate first. So if I multiply by the conjugate, I get square root of x plus 1 minus square root of x over x plus 1 minus, this is really nice. This is really nice. So if I multiply by the conjugate, it turns out to be a very nice result. Square root of x plus 1 minus square root of x dx. Oh, that's Mickey Mouse. So the key step is only multiply by the conjugate. That's the key step. Okay, so this will be 1/2 becomes 2/3. 2 over 3 x plus 1 to the power of 3/2 minus 2 over 3x to the 3/2 plus constant. I multiply by the conjugate. So what I had was like that 1 over square root of x plus 1 square root of x. I multiply the top and the bottom by the conjugate x, square root of x plus 1 minus square root of x over square root of x plus 1 minus square root of x. So that I can utilize difference of squares on the denominator. I get x plus 1 minus x, while on the top, I have those two terms.
And then, oh, sorry.
And then I think we are done here. I don't think we can simplify any further. I don't think I can simplify any further. How do I get rid of x plus 1 minus x? Just do x plus 1 minus x. What do you get? The top term is half of the denominator. No.
I think he's talking about the second step, which I'm confused about, is how do you get it from the fraction to just...
You're thinking way too hard. X plus 1 minus x is what? You must be tired. Yeah. Okay. Yeah, let's take a break. You must be tired. Let's take a break right now. It's 9:20 approximately. We come back at 9:30. And if you have more questions, let me know. Okay. Yeah. Yeah, it must be very likely you're just tired. Pause the record. Okay, any other question from here maybe? From 7.5. Now, to be honest with you, I look at numbers 81, for example, I have no clue. Integral square root of 1 minus sine x dx. How to do this? Conjugate again. So let's multiply by the conjugate integral square root of 1 minus sine x multiplied by square root of 1 plus sine x over square root of 1 plus sine x dx. Now then on the top I will get square root of 1 minus sine squared x, and at the bottom I have square root of 1 plus sine x dx. But on the top, 1 minus sine squared x is cosine squared x. Under square root, it becomes cosine x. Oh, okay, then anything from here, just substitution then, huh? So u equals to 1 plus sine x, right? Such that du equals to cosine x dx. Oh, nice. Okay, so this is integral of du over square root of u. You can take it yourself. Okay, I guess no more question from here. Let me go on to 7.8. Of course, in 15 minutes, I cannot finish 7.8, definitely. I give you the ideas. Okay, 7.6, that's integration using tables. Okay, I don't go to that area. 7.7, approximate integration. I prefer to have a computer with that to do that. 7.8, improper integrals. 7.8, improper integrals. Now, I don't expect you to, you're supposed to have watched up to 7.8 though, according to what I see in the lesson. Okay, but if you have not, please catch up during this weekend. Okay, on Wednesday you have a test. Now then, during this weekend you catch up to 7.8 and 8.1. Now, but yeah. So in case, my assumption right now that you have not done this improper integrals. So I give you the skeleton, the framework first. Okay, what we call improper integral, there are two types. Type 1 the one involving infinite interval of integration. So either you have something to infinity or negative infinity to something, or even negative infinity to infinity. Now, the plan is if we have type 1 idea, when we deal with integral from a to infinity, we will integrate it this way. So we'll integrate this way. Let's say this is the integral from a to infinity. Supposed to be up, go there, right? All the way to infinity. But the plan is as the following. We will integrate up to t first. We'll integrate up to t first. After you're done with the integral, then you will send this t goes to infinity. That's the plan. Okay, so we can say integral from a to infinity is basically integral from a to t. Let me use red color here. Yet you bring that t goes to infinity. Okay, because integral to infinity, you're supposed to plug in infinity into your whatever x you have later on. But we never really do that. We always use idea of limit in place of infinity. Okay, now likewise, if we have integral from negative infinity up to a certain number, we will actually see that as integral from t to integral from t to a. But yet you bring the t later on, push it to negative infinity. Okay, so the second interval, let's say, the second interval, let's say you need to integrate from negative infinity up to a. Okay, now the idea is you integrate from t first, integrate from t to a. Whatever the result of that integral, then you push the t goes to negative infinity. Okay, now what happens if we have negative infinity to infinity? Then we break it up somewhere in between. And then from there, you use limit. Now, the warning here is that when you use the limit, okay, do not use the same variable. Okay, so let's say this one t goes to negative infinity, so t to a plus limit. Don't use t anymore. Okay, let's say I use s goes to infinity, integral from a to s, like that. Okay, in other words, the speed of t goes to negative infinity should be independent of the speed s goes to infinity. Okay, we should not use the same variable. It has to be totally independent. Now that's the idea for the first part of this improper integrals. This section actually consists of 3 parts. So let me tell you first those 3 parts. The first one is the type 1 involving infinite interval. Type 2, the one has singularity, where the function has infinity, like if you have asymptotes. Okay, and then the third discussion of this section is on comparison tests. So we do type 1 only for now. Of course, during this weekend, I want you to watch that video on that 7.8 and if possible, go on with 8.1. Okay, but let's do problems. Suppose, for example, I pick question number 8. Integral from 1 to infinity of 1 over 2x plus 1 cubed dx. Then change that infinity to something first. And then you basically will work on these. But of course, you still need to write the limit though. Okay, you still need to write the limit. Okay, now to do that, I use substitution. Basically the way we did it before. Okay, so this integral becomes from 3 to 2t plus 1. Okay, so this is 1 over u cubed, and this is du over 2. Let's limit t goes to infinity of integral from t3 to 2t plus 1, and then u to the negative 3 with 1/2 at the front. Limit t goes to infinity of, I believe that's negative 1/4 u squared at the bottom from 3 to 2t plus 1. That's limit t goes to infinity of 1 over 4 times 3 squared minus 1 over 4 times 2t plus 1 squared. And this is 1 over 36 minus limit t goes to infinity of 1 over 4 times 2t plus 1 squared. But that's equals to 0. Number 18.
I have a question, Thomas.
Okay.
Does L'Hopital rule ever come into play for this section?
That's actually the main reason why we need to use that limit, because there are cases where you need to use L'Hopital rule.
Okay, for sure. So we will be using it in this section as well. Okay.
Yes, yes. It's think of it this way though. It's more about using limit as to help us, and later on we may need to use L'Hopital rule. Okay, but that's not the main reason we use limit. The main reason we use limit is because we cannot integrate up to infinity. That's the main reason.
Got it. Thank you.
Number 18. Yeah, this is integral from 2 to infinity of d phi over phi squared plus 2 phi minus 3. Let me factor this first so that I have a feeling if I can really do this or not. This is phi plus 3 and then u minus phi minus 1. Now, what I meant by we can do it or not, because you see that we have singularity. It becomes undefined if phi is negative 3 or phi equals to 1, right? Okay, so we have the domain of this function the integrand is all real numbers except -3 and except 1. Now, the good thing is our integral actually starts from 2 to infinity. You see what I mean? Okay, so even though this integrand has singularity in the function, but it's not, happens to be not in the domain. So we still treat that as type 1. Limit t goes to infinity, integral from 2 to t of d phi over phi plus 3 phi minus 1. What is this? This is limit t goes to infinity of, I wonder if you remember this. Yeah, I wonder if you remember this. This is 1 over 1 minus -3 natural log of phi minus 1 over phi plus 3 from 2 to t. What the heck is that, Thomas? Where you get that? I know, you may not remember that. We get it from here. That's one of the formula I asked you to memorize. How did you get that first part? First part.
1 over 1 minus -3.
Oh, yeah, it's that's what I'm about to talk about. So just to remind you that, note, we did this before. Integral of dx over x minus a, x minus b is equal to 1 over b minus a natural log of x minus b over x minus a plus constant. I wonder if you remember that. We did partial fraction decomposition.
Was that B minus A or A minus B?
Repeat again.
That B minus A or A minus B?
I somehow believe that's B minus A. You can use A minus B. You can use A minus B, but then it will be A here and B here.
Yeah, okay.
Okay. Yeah, it's just the ordering though. So the way I see is a big minus small. X minus 1, -3 is smaller, so it's a big minus small. But the big on the top, minus small at the bottom. That's how I remember that. Okay, but that's what I did there. That's what I did there. So then going back to that limit situation. Now, otherwise you need to still show the the work, right? Okay, so it would be nice if you memorize that though. Yeah, partial fraction decomposition is not in your test 1, but you will see we actually have that a lot. Limit t goes to infinity of 1/4 natural log of t minus 1 over t minus plus 3 minus natural log of 1 over 5. That's limit t goes to infinity of 1/4 natural log of t minus 1 over t plus 3 in absolute value. And this becomes plus natural log of 5. Okay, I hope you realize that natural log of a fraction is equals to the opposite of the natural log of the reciprocal. Now then, I get 1/4 limit t goes to infinity of natural log of 1 minus 1 over t over 1 plus 3 over t plus natural log of 5 that's equals to 1/4. When I apply t goes to infinity, that will be natural log of 1 plus natural log of 5. Natural log of 1 is 0. So this is natural log of 5/4. Okay. Now notice that if you don't use that limit, if you don't pull out the limit, then you will have hard time here when you plug in infinity. Infinity minus 1 over infinity plus 3, that will be undetermined case, right? Okay, and it's not doable, actually. You get stuck there. That's why we pull the limit out first, pull the infinity out first, so that we don't need to deal with infinity heads on anytime in between. Okay, that's the reason we use that limit condition. Okay, now on Monday, I will continue from this 7.8, but I believe on Monday we will do 7.8 and hopefully we have a chance to do 8.1. Okay, but please do well in your test 1 here on Wednesday. Okay, and that's for today. Spring break can't come soon enough. Hey, actually your spring break comes soon. Do you know when your spring break start? I wonder if you know this. Do you know when your spring break start? Anybody can answer me? April the 5th? Actually earlier than that. So I hope that's a good news. Okay, according to schedule of class, okay, your spring break actually from April the 2nd to April the what? Let me see, where's my calendar? April the 2nd to April the 9th. Okay, sweet. But Thomas, our class is Monday, Wednesday, so it's just still the same. The spring break only 2 meetings for us, right? Actually, no. Actually, no. If you think about, if you look further, we have day off on March the 31st. Cesar Chavez. Okay, so what happened is you actually get your Wednesday before the spring break off and then spring break off. Now, the strange thing is, I need you to be aware with this. Be aware that April the 1st has class. So it's just like April the 1st, the day after March the 31st, but before the spring break, you have class. I don't know why they did it that way. Yeah, April Fools, but you need to come to class. Okay, now it depends though. I know some teachers, they already take their pre-spring break. So usually on April the 1st, that suddenly a lot of teachers actually call in sick, or they just like in this situation, they just like cancel the class, you know. But in my case, my Monday, Wednesday class, I legitimately don't have class. And I don't, this is the worst April Fool joke that we get for many years. It's like, why don't you just move that March 31st to April 1st, you know? Okay, but hey, I'm the lucky guy, right? Tuesday, Thursday class is the one not lucky. Yeah. Okay, so so on Wednesday, please remember we have a test, and then on Monday, I hope you do 7.8, and we already watched 7.8 and 8.1 at least, maybe even 8.2, but I don't want to go too fast anyway. Okay, see you then.